Your body burns 75% less energy walking on two legs than a chimpanzee burns on all fours. That number comes from a 2007 UC Davis study, and it explains something most people have completely backward. Walking is not the lightest form of exercise. It is the single most powerful input your brain has ever evolved to expect. Stop giving it, and your ability to learn, remember, and think clearly falls apart faster than any textbook can explain. Most people treat walking like a consolation prize. They say it when they feel guilty about not running, not lifting, not doing something harder. At least I walked today, as if walking were the bare minimum, the leftover, the thing you do when you cannot do the real exercise. That belief is not just wrong, it is biologically upside down. Your body did not evolve to run marathons. It did not evolve to bench press. It did not evolve to sit on a rowing machine for 45 minutes. Those activities exist because modern humans invented them. Walking exists because 6 million years of evolution sculpted your skeleton, your muscles, your cardiovascular system, and your brain around one specific movement pattern, putting one foot in front of the other across open ground. Daniel Lieberman, professor of human evolutionary biology at Harvard, has spent his career studying why the human body moves the way it does. His research consistently shows that bipedal walking is the foundational physical behavior around which every other human system organized itself. Your pelvis tilts, your spine curves in an S shape, your Achilles tendon stores elastic energy, your gluteus maximus, the largest muscle in your body, exists primarily to stabilize you during upright walking. No other primate has one that size. Every one of those adaptations serves walking. Not sprinting, not cycling, walking. And here is what matters for anyone trying to learn, study, or keep their mind sharp past 50. Your brain did not evolve separately from your legs. It evolved because of them. The question is, what exactly does walking do inside your skull that no other activity replicates? The answer involves three mechanisms that most educators have never heard of. The second mechanism is the one that will change how you think about studying forever. But to understand it, you need to know what your brain is doing the moment your feet start moving. When you walk, your visual field changes continuously. Objects near you stream past quickly. Objects far away drift slowly. This pattern, called optic flow, is something your brain has been processing for millions of years, and it does something remarkable to your neurology. Andrew Huberman, professor of neurobiology and ophthalmology at Stanford University, has described how forward movement through space generates a specific type of lateral eye movement. Your eyes track the passing environment from side to side, even when you are not conscious of it. This lateral scanning pattern activates circuits in your brainstem, particularly in the superior colliculus, that suppress activity in the amygdala, your brain's threat detection center. In plain terms, walking tells your brain it is safe, not with words, not with thoughts, with physics. The motion of the world flowing past your eyes triggers an ancient neurological signal that lowers anxiety and reduces the stress hormones bathing your prefrontal cortex. Why does this matter for learning? Because your prefrontal cortex, the part of your brain that handles working memory, logical reasoning, and new information processing, functions worst under stress. Cortisol, the primary stress hormone, directly impairs long-term potentiation, the cellular mechanism by which neurons strengthen connections and form memories. When your cortisol is elevated, your ability to encode new information drops measurably. Walking reverses that, not in theory, in measurement. Here is the study that nailed this down. In 2014, researchers Marilia Pezzo and Daniel Schwartz at Stanford University published findings in the Journal of Experimental Psychology, Learning, Memory, and Cognition. They tested 176 participants across 4 experiments, comparing creative output during walking versus sitting. The results were specific. Creative output increased by an average of 60% when participants were walking. In one experiment, 100% of participants who walked outdoors generated at least one high-quality novel analogy, compared to just 50% of those who sat indoors. And here is the detail that surprised even the researchers. Walking on a treadmill facing a blank wall produced nearly the same boost as walking outdoors. It was the movement itself, not the scenery, that changed the brain. Think about what that means for your learning. If you sit at a desk for 3 hours trying to absorb new material, your cortisol is rising, your amygdala is firing, and your prefrontal cortex is progressively losing its ability to process what you are reading. But if you stand up and walk for even 10 minutes between study sessions, you neurologically reset the system. You lower the chemical that blocks memory formation. You activate the circuit that calms the threat center, and you return to your material with a brain that is measurably more capable of encoding what it reads. This is not a wellness tip, this is applied neuroscience, and it directly connects to something even more powerful happening deeper in your brain, in a structure the size of your thumb. But here is the part nobody mentions. What walking does to that structure over time is so dramatic that it effectively reverses one of the most feared aspects of aging. That structure is your hippocampus, a seahorse-shaped region buried deep in the temporal lobe on each side of your brain. It is the gateway through which every new memory must pass, every name, every fact, every skill, every face. If your hippocampus is healthy, information flows into long-term storage efficiently. If it is shrinking, and in most adults it is, your ability to learn declines with it. Here is the number that should concern you. The hippocampus shrinks by approximately 1 to 2% per year in older adults without dementia. That is not a worst-case scenario, that is the normal rate of loss. By age 70, many people have a hippocampus that is 10 to 20% smaller than it was at 50, and that volume loss directly correlates with declining memory. If you have ever walked into a room and forgotten why you went there, if you have ever read a page and realized you absorbed nothing, your hippocampus may be smaller today than it was last year. That is the mechanism behind the memory loss most people attribute to just getting older. But in 2011, Kirk Erickson and a team of neuroscientists at the University of Pittsburgh published one of the most important exercise studies ever conducted. It appeared in the Proceedings of the National Academy of Sciences. 120 older adults, average age 67, were randomly assigned to one of two groups. One group walked for 40 minutes 3 times per week. The other group did light stretching. After 1 year, the stretching group showed the expected decline, a 1.4% reduction in hippocampal volume, normal aging, predictable loss. The walking group's hippocampus grew by 2%. Sit with that number. A 2% increase effectively reversed 1 to 2 years of age-related brain shrinkage in adults whose average age was 67, using nothing more than moderate walking. The mechanism behind this is a protein called BDNF, brain-derived neurotrophic factor. Some researchers call it miracle grow for the brain, and while that phrase is informal, the science behind it is not. BDNF stimulates the growth of new neurons in the dentate gyrus, a subregion of your hippocampus where neurogenesis, the birth of new brain cells, actually occurs. Walking elevates BDNF levels in your bloodstream, and Erickson's team found that the participants whose BDNF increased the most also showed the largest hippocampal growth. If this is landing for you, if you are starting to understand that walking is not just exercise, but a direct input to your brain's ability to learn and remember, subscribe now. Because the third mechanism I am about to explain is the one almost nobody discusses. It involves what your brain does when your body is in motion, but your mind is not focused on anything. That section comes in 3 minutes, and it may be the most important part of this entire video. Here is the empathy moment. If you have been struggling to retain new information, if studying feels harder than it did 10 or 20 years ago, it is not because you are less intelligent. Your brain has been physically shrinking in the exact region responsible for forming new memories. And the single most effective non-pharmaceutical intervention to reverse that shrinkage is a 40-minute walk. Depending on who you ask, walking may be as effective as some cognitive-enhancing drugs for memory preservation without a single side effect. What almost nobody talks about is what your brain does during walking when you stop trying to think. There is a network inside your skull called the default mode network, the DMN. It activates when you are not focused on a specific task, when your mind wanders, when you stare out a window, when you daydream. For decades, neuroscientists dismissed the DMN as background noise, the brain idling. We now know that interpretation was completely wrong. The DMN is where your brain consolidates memories, makes connections between distant ideas, and rehearses information you recently absorbed. It is your brain's internal processing mode, and it is essential to learning. Here is the problem. In modern life, the DMN almost never gets to run. You check your phone, you listen to podcasts, you scroll through news. Every waking minute is filled with external input. Your brain never gets the unstructured processing time it needs to take what you have learned and wire it into long-term memory. Walking without headphones, without a phone, without directed conversation is one of the only activities that reliably activates the DMN while simultaneously providing the BDNF surge, the cortisol reduction, and the optic flow signaling we already covered. It is the neurological equivalent of defragmenting a hard drive while simultaneously upgrading the hardware. A 2022 study published in Nature Scientific Reports by researchers at the University of Maryland found that older adults who walked on a treadmill 4 days a week for 12 weeks showed measurably stronger connections between brain networks, including the DMN, and significantly improved story recall. These participants were not studying, they were walking, and their brains became better at retaining narrative information. Let that register. Walking, without any cognitive training, improved memory for complex verbal information in older adults. Not by teaching them a technique, by changing the physical structure and connectivity of their brains. Ben Shofty and colleagues at the University of Utah published research in 2022 in the journal Molecular Psychiatry, demonstrating a causal link between default mode network activity and creative thinking. Not just a correlation, a causal link. When the DMN was disrupted, creative output dropped. When it was active, creativity surged. Now connect the dots. Walking activates the DMN. The DMN drives both memory consolidation and creative insight. Walking also floods your hippocampus with BDNF, grows new neurons, reduces cortisol, and calms your amygdala through optic flow. No pharmaceutical, no app, no study technique on Earth does all 5 of these things simultaneously. Historians still argue whether ancient Greek philosophers walked while teaching because they intuitively understood this neuroscience or simply preferred the outdoors. Aristotle's school was literally called the peripatetic school, from the Greek word peripatein, meaning to walk. His students learned while moving. 24 centuries later, the science finally explains why it worked. So the question becomes, if your brain was built for this, if every circuit in your skull expects walking as a daily input, how do you actually use it to learn faster, retain more, and think more clearly? Here is a concrete system. 5 steps. Each one is backed by the research we just covered. Each one is something you can start today. Step 1. Walk for 10 minutes immediately after every study or learning session. The Erickson study at the University of Pittsburgh showed that BDNF levels rise during and after moderate walking. BDNF is the protein that strengthens synaptic connections and promotes neurogenesis in your hippocampus. When you walk right after learning, you deliver BDNF to neurons that were just activated by your study material. The timing matters. Walk within 15 minutes of finishing. Do not check your phone. Do not listen to a podcast. Let your default mode network process what you just absorbed. Step 2. Walk for 40 minutes 3 times per week at a brisk pace. Brisk means you can still hold a conversation, but your breathing is noticeably elevated. This matches the protocol in the Erickson 2011 study, the one that produced a 2% increase in hippocampal volume over 12 months. You do not need to run. You do not need a gym. You need shoes and 40 minutes. Step 3. During your long walks, practice recall. This is where walking becomes a study system, not just exercise. After you have read or studied something, walk and actively try to retrieve the key points from memory without notes. This is spaced retrieval practice combined with the BDNF boost and cortisol reduction that walking provides. It is 2 proven learning techniques stacked on top of each other. Dr. Henry Roediger at Washington University in St. Louis has published extensively on retrieval practice since the early 2000s, showing it is the single most effective method for long-term retention. Walking while recalling supercharges it. Step 4. Use the 20-minute rule for creative problem solving. The Stanford study by Opezzo and Schwartz showed that creative output peaked during walking and continued for a short period after sitting back down. If you are stuck on a problem, if you cannot see a connection, walk for 20 minutes with no audio input and let your mind wander. Then sit down and write immediately. You will have access to ideas your seated brain could not generate. Step 5. Walk first thing in the morning for at least 15 minutes before any focused mental work. Your cortisol peaks in the first 30 to 60 minutes after waking. This is called the cortisol awakening response. A morning walk uses optic flow and vagal activation to bring that spike down faster than sitting with coffee. You arrive at your desk with a calmer prefrontal cortex and a brain primed to encode new information. If even one of these steps was new to you, hit like. It tells the algorithm to show this to more people who need it. Dr. Wendy Suzuki at New York University has been teaching these principles to her own students since publishing her research on exercise and memory. She describes walking as the most transformative, zero-cost cognitive tool available to any adult at any age. Step back from the details for a moment and consider the full picture. Your species spent 6 million years walking. Your skeleton is shaped by it. Your muscles are calibrated for it. Your brain evolved inside a body that moved across open ground every single day, covering 5 to 9 miles on average, depending on which anthropological estimates you follow. Your hippocampus, your prefrontal cortex, your default mode network, your BDNF system, your cortisol regulation, all of these systems were built under the assumption that you would walk. And then, in the span of about 70 years, less than a blink in evolutionary time, we stopped. We sat in cars, we sat at desks, we sat on couches, and we wondered why our memory declined, why focus became harder, why creativity felt like a struggle, why learning something new at 55 felt fundamentally different than learning at 25. It is not because your brain is old. It is because your brain is starving for the one input it was designed to receive every single day. The research is not subtle. Walk 40 minutes and your hippocampus physically grows. Walk 10 minutes after studying and your retention improves. Walk without headphones and your default mode network wires new connections between ideas you could not have linked at your desk. I want to hear from you. Drop a comment below. Tell me, do you walk after studying? Or have you been doing all your learning sitting down? I would bet that after watching this, your answer changes this week. Your brain does not ask for much. It asks for movement. That is the line. Your brain was never designed for a chair. It was designed for a path. And the moment you start walking that path again, 10 minutes, 20 minutes, 40 minutes, your ability to learn, to remember, to think clearly does not just stabilize, it comes back. Share this with someone who is trying to learn something new, a language, a skill, a certification. And if you have not subscribed yet, now is the time. What I am working on for next week goes deeper into memory systems than anything I have published before. Your feet already know the way. Your brain is waiting for the signal.